there we are. In 1 second, just to make sure I got everything squared away here. Okay. All right, so this is a 3090 EVGA, which is no longer in existence. Of course, GeForce, NVIDIA, all those things. RTX, but very good card. This is the FTW3, one of the more popular cards that was ever, really ever around. So, very cool card. And with today's modern prices of hardware and things, we're gonna, come through here and leverage what we have, because what the 3090 has that the modern cards don't, at least consumer level cards, is NVLink. So this is our way to kind of leverage existing hardware that's not getting any cheaper and be able to do some modern things with it, such as AI. So this will do things the 5090 will not once we're done. And so today we're going to really work on just repadding this, getting it all cleaned up, doing all those different things. So that's kind of the fun part here. And we're going to use a few different things. From the manufacturer, they use both thermal pads and also a thermal paste. And what we're going to do, and that's totally correct, but what we're going to do is actually use a thermal conducting material instead of the paste and some putty instead of the pads. The reason for that is because our use case is going to be, running AI day and night, not just doing some gaming here and there. So the longevity of the thermal material we're going to use is a lot better. So instead of doing kind of the traditional way of the paste and the pads and having it maybe only last weeks, especially with the paste, this will give us a lot longer kind of runway as far as all that goes. So that is our plan with that. And we will, first one. So we're going to start by just cleaning this all up. Mostly I'm going to use isopropyl alcohol. You can use, whatever, but I use the good stuff, 99%. And then I have this whiteboard. I'm just going to be peeling the pads off. This one, of course, was repadded before, not by me. I opened this up last night on TikTok. You can see that some of the pads, it's kind of hard to see, but have an indentation from the chips. So they made good contact and even maybe perfect contact. And then some of them you can tell had no contact. So what that is these cards in particular had on the different assortment of chips and MOSFETs here, had different varying rates of thicknesses of pads. So not everything's on the same plane. And even as by design, there's some, tolerance variant. So when you're gaming and stuff, you can get away with a little bit more of that. But for us, we're going to be running these cards hot and heavy for like 3 days at a time. So we're going to use, instead of a thermal paste, we're going to use this Honeywell 7950 thermal material. This is just going to not, it's going to stay put and be more durable on our main chip. And then in place of pads, because of that varying thickness of pad, there's ways to get around that, and it's perfectly acceptable. You can do different thicknesses of pads. You can stack pads, different thicknesses of pads to achieve what you want. But we have kind of a variety of 1, 2, and like 2.65 millimeter pads here. So I'm going to come through and use this really nice thermal putty. And I'm going to design in Fusion or SolidWorks after this short little cleaning stream some cookie cutters or some sort of ability to put our putty in a mold and kind of roll it flat, push it out, and like at least give us a starting point for thickness and then shape for the different sizes of chips. So maybe I'll be able to put that in one of the 3D marketplaces in the future. But again, not trying to defeat the purpose of the putty. It is to kind of like roll it out, put it on, and let it conform. But I want to give us kind of a starting shape. So I'm going to do that for our chipsets. But way we talk here, we can talk and walk. We're gonna start peeling off some of these, and just for fun, I'm saving these pads for now. Not really to reuse the pads, but just to have a point of reference as far as like, you know, what they look like, what kind of contact they made, where they came from. So I'm just orienting myself on this white foam here. And that way if I see any, you know, issues on here, I can kind of have a point of reference back and see if I can see any evidence on the thermal pads. So just my way of doing it. All right, so this cooling block looks pretty good. There's some original, they didn't do a very good job cleaning this when they originally did it. See if I can zoom in a little bit more without getting blurry and stuff. So there's a little bit of leftover thermal paste on here from the original guy. The original pads are that dark gray, so it's pretty obvious when they redid them in blue. So, you know, this is just kind of like, I would say they did an acceptable job because the Repad like functioned. I tested it. It was on the hotter side. However, you know, it's just not as clean and crisp as I would have done it here. So, all right. Now we're going to come over to the MOSFETs. And these you can reuse the pads, especially the originals. These ones I don't really know where they came from, but you can definitely reuse these on the originals. We're not going to because we're going to do putty, but you can see here there's a lot of leftover original pads on the MOSFETs, and actually it comes off really nice, which usually it's kind of baked on and we have to use an X-Acto knife to pull it off, just kind of scrape it off. So what that's telling me is actually this card had a pretty good life because this guy didn't do a great job cleaning, and the original material comes off pretty easy. So that's a good sign. I have one concern with one of the chips over here. It looks like it's got a little crack kind of, but we're gonna clean it up and get to that. Oddly enough, it didn't show anything when I stress test it on anything weird on any of the chips. So I'm gonna be kind of cautious about cleaning it because I want it to be reliable, but I don't want to like if something's kind of okay but not, you know, starting to have an issue. I don't want to kind of finish it off. I'll just note it, maybe prepare that. We use a 3090 because we're able to stack these with NVLink and use them together to solve bigger models. So bigger models are going to do more compute, like a 1590 card. Architecture technology is better, more efficient, but a 3090 has NVLink, which this is the last video card that NVIDIA did that was kind of consumer based. They still have NVLink, of course, on bigger commercial cards, but not on consumer cards. So this was the last one that was the biggest and last one that had it. That is still kind of attainable, if that makes sense financially. The new ones, new cards in general, I mean, they're all real expensive, and so is this, even a used one. With these cards, you take a little bit of a gamble, get them used, you know, eBay, wherever, Facebook Marketplace, Craigslist. You know, they could have been used for Bitcoin mining. They could have been cooked pretty hard. You know, people repadded them like this. There's some scammers out there that'll take a 3070 and put a 3090 stuff on it, stuff like that. So you really got to watch out for that. But anyway, these two cards, I just got two in, and one has not been opened. This one had been opened and repadded. I was missing a screw on the back, all those kind of good things. But anyway, it tested well. I tested them both. One's actually still running from yesterday, but they're running on a Threadripper machine I have that's kind of the same period as this, and yeah, that's kind of where we're at. So I'm going to use some different cleaners. I have isopropyl alcohol, and then I also have some petroleum-based kind of adhesive remover pads. And the reason for these is because alcohol cleans pretty much everything really good. These are a good way, or some of the electrical contact cleaner to really clean. They clean a little bit better. As far as these chips are pretty porous, so and then uneven, and so kind of the alcohol works plenty fine. If you want to just spit shine it a little bit better, these pads were good. And then also the original paste, and I don't know what, I'm assuming this isn't because it was repadded, but the original paste that EVGA used on these, you won't really be able to get off without rubbing alcohol. It's kind of a mess. So anyway, we're gonna start. Actually, out of curiosity, I kind of want to see if this wipes up. See what kind of thermal paste they used. Yeah, so I can already tell actually this isn't the original EVGA paste because, I mean, it wipes right off. To be honest, too, I think this, my assumption is this card wasn't used very much, or it was repadded recently. Because, yeah, it just really doesn't have a lot of wear and tear on it that way. Just grabbing some more paper towel here off screen. All right, let's go. Nobody wants to stare at me. There we go. So what I'm doing, so you can kind of see this cooling block here. Don't usually kind of spray directly on the part, but we're gonna do it right now for fun. And make sure, like, we're trying to clean, so I use kind of a higher quality paper towel. So you can use like a lint-free paper towel, Q-tip, cotton ball, all that kind of good stuff. Just want to make sure you're making it better, not worse, not leaving anything in there. You want to be careful too. You don't want to get any extra, fingerprints or oils on these surfaces. It'll decrease the efficiency of the cooling. So yeah, this is kind of a messy block actually. We're gonna get it cleaned up nice and pretty like. This one's kind of interesting. I'll find my tool here. This one has little kind of scored or scribed ears in the cooling plate to show you the position for alignment for the pads. So that's kind of cool. I would imagine those were from the factory, or from EVGA rather, placed on there and then mated to the board. We're actually gonna do it the other way around. We're gonna put the putty, in our case, directly on the chips. But like I said, I'm gonna make some sort of cookie cutter or mold after this today. So we want to clean all these surfaces. That's already cleaner than when we got it. So you want to make sure and clean obviously the big copper plate, and then we're going to clean both these rails or mounting surfaces too. And then not only there, but we want to make sure and clean kind of the lip up here, because it mates down here to these MOSFETs. So there's kind of a step there, I guess is what I'm trying to say. So make sure and clean that up. So I haven't even used these pads yet. I probably will. It's kind of a final pass, but right now I'm just really just trying to clean these little areas here. I just have a little spray bottle I use, just a little cheap spray bottle with isopropyl alcohol in it. All right. One thing too, sometimes there's like manufacturing slag, or get some kind of weird kind of textures on here. So like to be really make sure that it's cleaned up on there. And then we're gonna bust out one of these pads, just since there was some old manufacturing paste on here before. you can see the additional, see that gets off. That isopropyl alcohol, was it? Kind of interesting, huh? It's like you think it's so clean, but look at that. And that turned out pretty brown for having just cleaned it with isopropyl alcohol. Okay, and we just want to let everything kind of obviously dry off. And we're gonna kind of, let's see, before I do that, I'm gonna pull the pads off of, let's see, I'm gonna move some stuff around here off screen so I can get some better stuff in screen. Be real careful with all this stuff. Here's our little spring plate. We'll clean this too, but we'll do this probably more towards the end. And then I'm going to take, there's obviously chips on the back here, so and see, like this one, for example, is shiny still. I can't see that it made any contact with the pads, which is not a good thing. All right, so this is the same thing. Let me grab a little extra paper towel. Try to get the worst of it off. If you can't hear, I have a pretty typical bathroom dispenser of a machine here. All right, here's my little spray bottle of isopropyl. So yeah, we'll just take this and we'll just come in here. To get all this wiped off. Okay. And should be pretty good, I think. Yeah, see these plates can be a little wonky wavy-wise. This one's actually honestly pretty straight, which kind of surprises me. They're never straight. It's almost suspicious. So here's our card, and we'll just see this in multiple ways here in a second. But we have memory chips on the front and the back. So these are those ones I just took off that flexible plate. These are chips on the back right here. And I want to be really careful you don't bend or flex this card because or bang it around like that. It will pop some of the circuits that you don't want to pop. So try to support it and keep it nice and clean. I don't know what I'm going to do here. I think I'm going to use the paper towel to get off the worst of this. Thermal paste. I mean, everything looks okay. It doesn't look like it. Like I said, I don't think this got used much, to be honest. I think somebody was probably gaming with it and, you know, thought they needed to repad it, and maybe they did. But it looks like they repadded it early, or they just never used it and repadded it. So, let's open up a new one of these pads. Even though we haven't really cleaned much yet, it'll help us get in there a little bit better. There we go. So now you're gonna see the chip get all shiny. Gonna do our best to clean off all the extra crap that we can. Really trying to polish this up. It's kind of a, you know, slow process a little bit, especially when you get crap all over like this. I use plastic tools to kind of just clean it up in there. At the end of the day, this isn't going to hurt too much, but my real goal, aside from being clean, is it helps keep it cool, but I want to make sure the new thermal material, thermal conductive material I'm putting on here just has the best chance of getting, you know, good surface to surface without a bunch of blobs on the side trying to keep it from meeting flush or something like that. So kind of nerve-wracking because some of these chips are so small, these little components. That looks like some original stuff right there. It's a little bit harder. Yeah, you gotta be careful, you know, with the, it's just, I don't know, it's forgiving, but it's not, so I think as long as you try to be careful, you're fine. You don't like have to hold your breath, but you know, I try to be aware of like my X-Acto knife or my paper towel or how I'm scrubbing, because you know, you can snag a component and put enough pressure on it or flex a board to pop it. So pop it free, break a joint, bad things happen. And then you're in a whole different repair mode, so which we don't want if we don't have to. All right, one more paper towel here. I'm also going to, it's kind of making a mess here. I have these cool Q-tips. I got like an assortment of them on Amazon for my buddy Jeff Bezos that we're all friends with. So what I usually do is I just come in here and I'll just spray my tip with isopropyl alcohol, my swab. Okay, we're gonna come back through, just kind of clean up these chips. Looks like they were cleaned before. Okay, not great, okay. But we want to make sure there's no fat fingers from the previous person on there. So, man, it's getting kind of dirty already. So it's kind of interesting. Let's see. Yeah, that one definitely has. That's so weird. Say like one of our chips is cracked, which is kind of weird. And I don't really understand. Why it's cracked like the way it is. I think for my testing it was still working fine, but alright. So I'm coming in. What's nice about this is it's getting it really clean here. Getting a lot of that out of the corner. Got almost all of it out actually. Might need one more of these Q-tips, or these swabs. Did such a good job. So one thing you'll see is these chips should be a little more black and shiny. They don't have to be perfect, but see they have a little more of a haze to them. That's still some of that kind of original compound. And so that's where I'm going to come through and actually use one of these pads, because I think we'll get some more of that original EVGA material out of the pores. Which will promote good adhesion for our new pads, and then also you know, just help our thermal efficiencies. we get that guy right there. All those guys. All those guys. Still not really sure what the story is on that one. It's got a little crack almost in it, but it's real weird. It's like a round crack, but it's almost like a perfectly round, which is unusual. All right. So now that we got that out of the way, let's see. I'm going to actually grab. I need one more of these these swabs here. Just to kind of clean it up. The other stuff does the deep cleaning, but we'll kind of come back and polish it here a little bit. There we go. Feeling pretty good about that. Of course, I want to make sure this is nice and dry before we go. Getting too fancy here. But cool. I'm gonna eventually here, I'm gonna take a picture of this one little spot. For a couple reasons. Might do a little digging into that. Uh-oh, what did we do? We lost our forward camera, which might have been my fault. No signal. Oh, jeez. I didn't do it. All right. So, anyway, we got the one that matters. Top down. All right. So, we're pretty close, I think, actually, to done on this side. I'm going to clean up a little bit more, I think. But I want to tackle this side real quick. There's some random something there, which we don't want. And we're just going to come through with our swab. Kind of pre-clean them all. There's not really honestly much residue left on these. That tape from the Repad, I don't know that it cooked enough to really be a problem. But we'll give them one quick scrub just because they are important. Okay. And I think we'll come back with our final alcohol. Just kind of get the last little bit of that off there. Cool, seeing that evaporate, got it pretty cleaned up. So yeah, didn't do too bad. I think I might do one last pass here on our chip with some isopropyl alcohol. Running out of my favorite Q-tips, or my favorite swabs here. Not really a Q-tip, I suppose. They're fancy something or others. Plenty clean, just, you know, trying to get it as nice as possible. So I don't have to do it again, and so it'll be maximum efficiency and all those things. So I can have some focus on having fun with AI things we're doing and not have to worry about everything else. Seems like no matter what, I can't get that to quit smearing there. Which means there's a little bit more every time that we're getting loose. Hey, there we go. Now it's shiny. Check it out. Pretty clean. All right. Set down gently. So I think we're pretty well cleaned up. So that's essentially it. The only other step we'd have, sometimes use some dental picks very carefully, plastic picks to come in and get around different components, get some of that old pad or paste off, and then we can use an X-Acto knife to kind of, there's some different blades you can use, but usually like a 1/2-inch square blade or an angled blade, and come in at an angle and just, we can peel off everything on our way down, peel the pads off. But since this was already repadded, we didn't have to do that on this one, but we will on the next one most likely, so because it hasn't been opened. So that's kind of how it shook out. So we got all our stuff. This spring plate, I usually just kind of wipe it down. Is really all I do with isopropyl alcohol. So I'll do that real quick. That's pretty much the end of the stream. I'm gonna make some things to 3D print, and I'm gonna make some little things to help rebuild some of this. There's real simple little cookie cutters I'm gonna do, and then yeah, we'll be ready to come back and do some more here probably tomorrow. Come back in and see if we can start putting them back together once my cookie cutters are done. So that's it.